Okay, we need to be able to graph complex numbers, express them in trigonometric form, and then use the theorems for finding their product, powers, quotients, or roots. So let's start with graphing. I'm going to graph them up here at the top because I just don't have a lot of room on this slide for everything. So I would take negative 3 square roots of 3 over 2, which is about negative 2.6. And so I'd go over that, and then I would go up 1.5. And that, remember that the x-axis is the real axis and the y-axis is where you plot the imaginary piece. So if I wanted to plot w, 3 square roots of 2 is about 4.25, so 1 2 3 4, and then we need to go down about that far, and w would be like this. So plot the real piece and then the imaginary piece. So it looks like Z is in quadrant 2 and W is in quadrant 4. Now let's go ahead and get these in the trigonometric form so we can then do various operations on them. So remember, for trigonometric form we need to find R, and R would be the length right here, and so we can see that's just basically a Pythagorean theorem. So I need to take negative 3 squared roots of 3 over 2 squared. Let's see, that's going to be 9 times 3, that's going to be 27 fourths. It's going to be square rooted plus 9 fourths. So it looks like that's going to be 36 fourths, which is 9, and the square root of 9 is 3. So our modulus is 3, and then we'll have CIS, and now we need to figure out our angle. And so for our angle, we're going to do inverse tangent of 3 halves, and I'm going to go ahead and flip the other one, negative 2 over 3 square roots of 3, because I divided by it, so I flipped it so I could simplify. And that looks like that's negative 1 over square root 3. So we can see what that's going to be. When I do this, I'm going to need to be in quadrant 2, and the tangent is negative 1 over square root 3. That's actually something on my unit circle. That's going to be 5 pi 6. So 5 pi 6. Because if we figured out for 5 pi 6, the sine is 1/2, and if I put that 1/2, and then the cosine is negative square root 3 over 2, and when I flip it over to simplify, you can see I get exactly what I needed. Okay, so there we've got Z. Now let's figure out W. So for W, we need to figure out our modulus, so we need to square the 3 and square the square root of 2, so that's going to end up being 18. And then the next one's going to be 18 as well. So it looks like that one is the square root of 36, which is 6. So we've got our modulus. Now let's figure out our argument, or our angle. Okay, so we're down here in quadrant 4, and we had same x and same y, except that except that the y was negative. So when we do the inverse tangent, it's going to be of negative 1, but we need down there in quadrant 4, so that's going to be negative pi fourths. Typically our book likes to have these listed from negative pi to pi, so that'll be a great way to list those, so we're on that interval for both of those. Okay, now we're ready to combine. If you need the product, you multiply the moduli and add the arguments. So what I'm going to do is I'm going to multiply the 3 and the 6, 18, CIS. I need to add the arguments. So 5 pi 6 minus pi fourths, and I'll go ahead when I write it down and convert them. In fact, maybe I'll write it down here. I'm converting them to a common denominator of 12ths so I can see how to deal with them. So multiply those by 2, multiply these by 3. So if I add those together, I didn't write the 12, so this is a 12. So if I add those together, they now have a common denominator, and it looks like I get 7 pi 12ths. So this is the answer in trigonometric form, but we want to get the answer back into a plus bi form. And so the way that we do that is we just simply work it. So in other words, we do 18 cosine 7 pi twelfths, and I'm just going to use the calculator, and then I'm going to round to 2 decimal places. So that's negative 4.66, and then I'm going to do 18 sine 7 pi twelfths, and that's going to be plus 17.39, so that's I. So there is the product, Z times W. Now, if we want the quotient, Z over W, I divide the moduli and I subtract the arguments. So I want Z over W, so that's going to be 3 over 6, which is 1/2, and then CIS, and I subtract the arguments, and I'm going to do Z, which is the 10 pi twelfths, and subtract the W's argument, and subtracting a negative will make it a positive, so it looks like I'm going to get 13 pi twelfths. Now I could write this as 13 pi twelfths, but if we're trying to follow this, be on this interval, 13 pi twelfths is the same as negative 11 pi twelfths, but I'm now on my interval. So there it is expressed to have that interval from negative pi to pi for the argument. Now I need to get the calculator and I need to work this out. So 1/2 cosine of negative 11 pi twelfths is negative 0.48. And then 1/2 sine of negative 11 pi twelfths is negative 0.13, and I need to put the I on that term. So there is my quotient, Z divided by W. Okay, the last one, we're going to raise it to a power. This is Moines Theorem, which is, it's based on just doing the product, in this case doing a product 3 times. So what I do is I take the modulus and I raise it to that power. So that's going to be 6 to the 3rd, which is 216, and then CIS, and then we multiply the angle by the power. So I need to multiply the negative pi fourths by 3, so that'll be negative 3 pi fourths. Now I want to work that out, and because this is a point on my unit circle, I am going to do this one in exact form. So 216 cosine of negative 3 pi fourths. The cosine of negative 3 pi fourths is negative square root 2 over 2, and the 2 can reduce with the 216. So this is going to be negative 108 square root 2. So I had 216 and I had square root 2 over 2, and so I just reduced the 2 in the denominator with the 216. Now the same thing's going to happen for the sine, because I'm down in quadrant 3 at negative 3 pi fourths where they're both negative, so I'm going to get the same value, and that needs an I on it.